The objective of this lesson is to draw open area models to represent 1-digit by 3- and 4-digit multiplication problems using the distributive property. Prior to this lesson, students have practiced representing multiplication of 2 digits by 1-digit numbers using base 10 and open arrays. Here are some vocabulary terms we will use in this lesson. Decomposing breaks a number into place value or expanded form. For example, the number 372 is really 300 plus 70 plus 2. With open area models, a large rectangle is drawn and the factors are decomposed into place values of ones, tens, hundreds, thousands, etc. In an open area model, the rectangles are not scaled as they represent the partial products. A partial product is part of the answer to a multiplication problem. Partial products are added together using the distributive property to get the complete answer. Let's solve this problem using an open area model. The ski shop received a shipment of 7 boxes of stocking caps. If each box had 256 caps, how many caps did they receive altogether? First, draw a rectangle with 3 sections because the number of caps is a 3-digit number. Draw the columns with 256 decomposed into hundreds, tens, and ones. The 2 is in the hundreds place, so it is 200s or 200. The 5 is in the tens place, so it is 5 tens or 50. The 6 is in the ones place, so it is just 6 ones or 6. 256 equals 200 plus 50 plus 6. On the left side of the rectangle, write the factor 7 because they received 7 boxes of this amount. Now we calculate each part of the problem. Multiply 7 times 200, which is 1,400. Calculate the tens by multiplying 7 times 50 for the partial product of 350. Then multiply the ones, 7 times 6, which equals 42. Finally, students will add all 3 partial products to get the total number of caps delivered. 1,400 plus 350 plus 42 equals 1,792. We also ask the students to show their work using the distributive property. This is a second proof, and it leads toward skills needed as they advance into higher math. First, write the problem horizontally, 7 times 256. We are multiplying 7 times each part of 256, so we write 7 outside the parentheses. Inside the parentheses, we write the decomposed number, 200 plus 50 plus 6. Then we show that 7 is distributed or multiplied by everything inside the parentheses. 7 times 200 plus 7 times 50 plus 7 times 6. We put an addition sign between each set of the parentheses because we will add the partial products later. Now we multiply each part of the problem. 7 times 200 is 1,400, and 7 times 50 is 350, and 7 times 6 equals 42. Finally, we add all the partial products, and the total number of caps is 1,792. Let's try a 1-digit by a 4-digit problem. The school would like to put up 6 new basketball hoops on the blacktop outside the building. Each goal, including the cost of putting it up, will be $1,354. How much money must the school earn from their fundraiser to pay for all 6 goals? First, draw a rectangle with 4 sections because the dollar amount is a 4-digit number. Label the columns with 1,354 decomposed into thousands, hundreds, tens, and ones. Write the decomposed number as 1,000 plus 300 plus 50 plus 4. Then write the factor of 6 on the left side of the rectangle. Now multiply each part of the problem. 6 times 1,000 equals 6,000, and 6 times 300 equals 1,800, and 6 times 50 equals 300, and finally 6 times 4 equals 24. The partial products are 6,000 plus 1,800 plus 300 plus 24, which equals 8,124. Now write what you've done using the distributive property. 6 times 1,354. Put 6 outside the parentheses and decompose 1,354 into 1,000 plus 300 plus 50 plus 4. Now multiply 6 times everything inside the parentheses. 6 times 1,000 plus 6 times 300 plus 6 times 50 plus 6 times 4. And you will get the partial products of 6,000 plus 1,800 plus 300 plus 24, which equals 8,124. As students show their work using the distributive property, they will be more likely to catch any careless mistakes. As they see how the two ways relate, they will be ready for more challenging work and will move toward more efficient methods for multiplication as they gain confidence and understanding. The objective of this lesson was to draw open area models to represent 1-digit by 3- and 4-digit multiplication problems. We met this objective by showing the partial products using the distributive property in an open area model.